Hi, today we're going to be talking about the law of conservation of mass. So what this says is that all matter is going to obey this law, the law of conservation of mass. And what does that mean? It states that in a chemical or physical change, so that means whether you're changing states of matter, solid, liquid, gas, or whether you're rearranging bonds in an actual chemical change, matter can't be created or destroyed. So whatever number of atoms you have to start with, that has to be the same number of atoms you end with, because you can't make an atom and you can't destroy an atom. So if it's all there at the beginning and the end, no matter what the mass is at the beginning, so those are kilograms, is the general SI unit, but in the lab you're probably going to use grams. So however many grams you have to start with, that's the grams you're going to have to end with. So whatever it says on the scale at the beginning will be the total of what it says at the end. Some students will get confused about that because they'll think maybe like, oh, it made a gas, the gas doesn't have mass, but gases do have mass as well. So if your solid that's left over says something less than what you started with, then something was lost in the chemical reaction, probably in the air due to density, but the total mass is the same. So if you keep it in a closed system, as in nothing can escape, the mass at the beginning will always be the mass at the end. So let's talk about just like some really basics of writing chemical reactions. So when you're working out problems, remember that the mass of the reactants has to be equal to the mass of the products. In a general chemical reaction, I'm going to show you two ways to think about this. The first is the reactants form the products. So that arrow is yields or forms or rearranges to make. But then when you're talking about the mass and you're trying to solve for some numbers, we're going to put it in an equation. And when you have an equation, you need an equal signs and two things equal to each other. So the mass of the reactants equals the mass of the products. So when you do problems like this, you have to think about which things are reactants, which things are products. And then I have this little scale here to remind you that it's going to be the same on both sides. So whatever the mass is on the reactants, it's going to be the same as the products, so the scale doesn't tip in either direction. It's perfectly equal. So let's do a sample problem. 14 grams of nitrogen react with 3 grams of hydrogen to form ammonia. Calculate the mass of ammonia present. Well, when you read this, you kind of have to read it like a story. What happened? Well, I know that nitrogen came together with hydrogen and it made ammonia. So what things do I start with are your reactants. I have 14 grams of nitrogen to start, so that's going to be one of my reactants. And as a reactant, I'm going to put it on the left side of my equation. And that's reacting with 3 grams of hydrogen. So I'm going to add those together because those are both my reactants. And the masses of your reactants gets added together. You're going to separate that with an equal sign because it's going to form, so equals, but yields in the written out equation. Ammonia is your product. That's what you get. So when you write this in with your numbers, you've got 14 grams under nitrogen, 3 grams of hydrogen, equals some unknown mass of ammonia. So when we add these up, we're going to see that 14 plus 3, that's going to give you 17 grams of ammonia. Let's do another one. We have 16 grams of oxygen, and they react with carbon to form 22 grams of carbon dioxide. So we're going to calculate the mass of carbon that was used. So remember, you want to think about it like a story. All right, oxygen and carbon are reacting to form carbon dioxide. So what did you start with and what did you end with? Oxygen is something you started with. You needed to put it with the carbon to make something. And carbon is also what you started with. It's forming 22 grams of carbon dioxide. So that's the end product. So we've got oxygen and carbon are reacting to form carbon dioxide. Let's put in our numbers. 16 grams of oxygen. We don't know the grams of carbon, and that's going to make 22 grams of carbon dioxide. So we filled in this center here with 6 grams. How do you know that? Well, 16 plus what gives you 22? 16 plus 6 grams of carbon, so there's your answer. 6 grams of carbon is your final answer here. So in a chemical reaction, you're always going to have set ratios when you're dealing with your masses. And what do I mean by that? So let's look at this equation where you have magnesium reacting with copper 2 sulfate to produce copper and magnesium sulfate. And I know, based on calculations, that 24.3 grams of magnesium will fully react with 159.6 grams of copper 2 sulfate, and that's going to make 63.6 grams of copper and 120.4 grams of magnesium sulfate. Now, I got these from the molar masses. So I got these from the periodic table because I have a balanced chemical equation. And we'll go over balanced chemical equations later in the course. But I know that for every 24.3 grams of magnesium, I need 159.6 grams of copper 2 sulfate. Or if I use up 24.3 grams of magnesium, the max of copper I can make is 63.6 grams, etc., etc. So, for example, I also know that if I have 48.6 grams of magnesium, now where did this number come from? I said 24.3 and I multiplied it by 2. So if I have 48.6 grams of magnesium, then I'm going to need double my 159.6 grams of copper 2 sulfate, and that'll be 319.2 grams. If I use this new set, then the amount of copper I can make is doubled as well. So 127.2. The amount of magnesium sulfate that's produced is also double. So that would be 240.8 grams. Notice these are set ratios. All right, so whatever this is, I doubled it, which means this had to be doubled. This had to be doubled. So given these ratios provided, let's do a sample problem where what mass of copper 2 sulfate do you need to fully react with 380.2 grams of magnesium? So I'm going to go ahead and get rid of my products. Notice I'm only asking about copper 2 sulfate and magnesium, so I only need these two bits of information. Also, the first step is to set up a fraction with your known masses, and then the second set is to make a fraction that uses those same sets but with the new information. What do I mean by that? So I'm asking about copper 2 sulfate and magnesium. So I'm going to set a ratio of the mass of magnesium and compare that to the mass of copper 2 sulfate. So I write this down, and I want you guys to write that down as well, so I remember to put magnesium on top and copper 2 sulfate on the bottom, so you're consistent with your fraction, so you keep your ratio in the right order. So here's my copper 2 sulfate mass. This is the stuff that's given, so we're going to keep given information together in a fraction as well. So I'm going to make this ratio for every 24.3 grams of magnesium. I'll always have, so for every this, I'll always have that, 159.6 grams of copper 2 sulfate. Notice I kept magnesium on the top and copper 2 sulfate on the bottom, just like in the original that I set up. Now you could have done it in the opposite order. It doesn't need to be magnesium on top and copper 2 sulfate on the bottom. However, you just need to be consistent throughout the whole problem. So if you had put copper 2 sulfate on the top here, this fraction would be flipped and my later fraction would be flipped as well. But this is just how I'm using it. I like to keep magnesium first because it's the first thing listed in my chemical equation, and that just for my brain works better. All right, so I've done my first step. I've set up a fraction with the known set of mass ratios, and my second step is to make that equal to a fraction that has a new set of mass ratios, so including your unknown. So that's going to be equal to, well, what mass of copper 2 sulfate is needed to react with 380.2 grams of magnesium. So 380.2 grams of magnesium is the second part because it's what's given to you in the problem. And that's going to go on the top of my new fraction because I'm putting magnesium on the top in all of these. So I've got 380.2 grams of magnesium. I have a fraction here, magnesium on the top, copper 2 sulfate on the bottom. So this needs to be set equal to a fraction as well. And I'm saying X, because I don't know what the mass of copper 2 sulfate is. That's what I'm trying to solve. And once you have two fractions set equal to each other, cross multiply. So, cross multiply. Everything that touches arrows together, those get multiplied together. So we've got 24.3 times X from this cross. And then I have to do this part, which is 159.6 times 380.2. So that's going to be 60,679.9. Now I have a nice clean equation, a basic algebraic equation. I need to get x by itself to solve for it. Currently, I have 24.3 multiplied by x. So to get x by itself, I have to do the opposite function. The opposite function of multiplication is division. So I'm going to divide this left-hand side by 24.3 so that these will cancel and x will be by itself. Whatever you do on the left, you have to do on the right. So divide by 24.3 on the right. My 24.3's cancel on the left, and x is equal to 2,497 grams of copper 2 sulfate. Okay, that is the end of the show, so make sure you ask questions if you have any. Thanks.